Okay, so this video is going to show you and discuss section 3.2, which is understanding relations and functions. So what we're basically going to do is we're going to look at how we represent relations and how they're different from functions, and basically what these two things go together with our domain and range that we looked at yesterday, and how we can represent these a little bit different way than what I showed you of just kind of writing what those numbers are, but kind of talking about what they are in context of how we work with relations and functions. So first of all, we have a relation is a set of ordered pairs. So we're going to refer to a relation as just an ordered pair, x and y, similar to what we've done before. We have x, which is what we call the input, and y, what we call the output. So x, kind of thinking about an equation or anything that we have as far as how we plug in variables, where x is going to be what we plug in, and then y is going to be basically what we get as an answer based on what we plug in. So we can kind of look at it in terms of that way. So the domain is all the possible values of x that you can use, and so in this case we're talking about anything that you can put into the relation is what we call our domain, and the range is all the possible outputs of said relation. So when you think of it this way, domain is all the values that you could possibly plug in for an equation or an expression or anything else like that, and the range would be all the possible answers that you get as a possibility. And so this, that you use the example of the given relationship represents the number of whole wheat cracker boxes sold and the money earned. So the idea is that if you sell one box, you get $4 back as your output. If you sell two boxes, you get $8 as far as the money that you earn, and it keeps going in that way. And so here, as it shows you the domain, it's talking about how, oh yeah, you get 1, 2, 3 or 4 boxes that you can sell. You can make 2, 8, 12, or $16 as that kind of continues and as it goes in that potential way. So it's the idea of understanding that x is the input, what you put in, the y is the answers or the range that you get from that. So if we continue with this and we look at some of the things that we're doing here. So the following relationship, the input x is the ages of boys and the output is their corresponding heights. So when we look at these pairs, this pair represents one particular person and one particular scenario that we have going on. Doesn't necessarily mean that there's a certain pattern to it. We just know that it's a relationship. We know that there's a relationship between the age of a boy and his corresponding height. So what we can do is we can put these in a table to show that these things are related to each other. So if we look at this first one, the value of x, or my input, which is my age, you tell me an age and I can tell you the height, and then the corresponding height of that person is, 41. And so the idea is that ordered pairs can be put into a table, an x and y table. So at age 8, someone was 45 inches tall. At age 9, someone was 49. At age 10, we had someone that was 52. At age 10, we have another person that is 53. So the idea is that you could have multiple results for, different scenarios. It's just a matter of understanding that there's just different ways that we can collect information. At 11, there was somebody that was 55, and at 12, we had someone at 59. Now, it's important to notice that the idea of a relationship is that there doesn't have to be any particular pattern. If you notice, it doesn't go up by the same amount. So from 7 to 8 to 9 to 10, it didn't follow the same pattern. It didn't increase by the same value. And if you notice, we also had a value that repeated twice. And so that's the idea of a relationship, is that it can be pretty much anything that we want it to be. So this is just a scenario that we can make up, that we can say, hey, here's a bunch of information, this is how it relates to each other, and that's it. There doesn't have to be any pattern to that. And so if we graph this same information, we graph this in the same way that we did before. So we're graphing these as ordered pairs or as a table. So 7 comma 41, so we can go to 7 comma 41, which is roughly in this general area here. Now when we're graphing like this, it's okay to estimate. It doesn't have to be perfect as long as we get the same idea. So what I'm going to go ahead and do to kind of make this go a little bit quicker is I'm going to go through and I'm going to graph every single one of those points. So 8 comma 45, 9 comma 49, 1052, 1053, 1155, and 1259. Okay, so I put both of the values of 10 that we got two different heights from, I put those in different colors so that you could see those. But what I want to show to you is that even though this doesn't have a particular pattern, it still has a relationship. And this idea right here, this shows the relationship that we could basically say, or that we could basically interpret, that as a boy gets older, then he is going to get taller. And so there's still a relationship there. So that's why we talk about this as being a relationship, because something is happening with these values as they continue to increase or as they continue to decrease, whatever that scenario is. But the idea is that there's some kind of relationship to them, so we're graphing them so that we can see them, and then we're able to talk about all of this information at a different time. So this is how, and this is the basic understanding of how we graph relationships. Relationships are given to us as ordered pairs. We can put them in a table so that we can see how they're changing if we want to, and then we can also graph them so that we can see what they look like in comparison to everything else. Is there a pattern maybe, or is there something kind of going on that we want to look at? Now, the next way that we can show information is something that we call a mapping diagram. So the idea is that we place all of our domains. So in this particular case, we have our ages and we have our heights, which are going to end up being our range. And what we do with these mapping diagrams is that we show how the domain is connected to the range value in this particular setup, so that you can see that whether there are multiple things happening or just a single thing happening. And so the way that we look at this, the way that we complete a mapping diagram, is we take each piece of our domain and we connect it to its associated range value. So in this particular case, instead of showing an ordered pair, I can say that 7 relates to 41, 8 related to 45, 9 related to 49, 10 related to 52 and to 53, 11 associated with 55, and 12 associated with 59. Now the idea is that this allows us to see that 10, this value of 10, has multiple values of an output associated with it. And so that just kind of comes with the territory here, and so we'll just understand that we have a relationship here. And so our domain, the way that we write our domain is we'll say domain, and instead of writing it as a list of information, what I'll do is I allow myself to use what is known as a curly bracket. So I'll make a curly bracket and then I'll just list all of my domain: 7, 8, 9, 10, 11, and 12, and I end it with another curly bracket. But the idea of what I want to show you is that domain and range, if we for some reason have a number that is repeated, we don't put it twice, we only put that value once. So notice I did not put 10 twice on this mapping diagram because I only put it once, because it shows up multiple times, and that's why I use those that's why I use these bars over here to show that this value went to two different items in my data. And so we can do the same thing with our range. Again, we're only going to repeat these values just once. We do not need to write them twice for any reason. I'm going to write a curly bracket, and again, I'm just going to list all the values of my range. So 41, 45, 49, 52, 53, 55, and 59. And so it allows me to see all of these values, and again, don't repeat values. So I'll put that down here. Whoops. So we're going to do not repeat values in either the domain or the range. Okay, so that is kind of the relationship part. Now we're going to move into something that we refer to as being a function. Now a function is a relationship. So this is kind of like that idea that all squares are rectangles, but not all rectangles are squares. And so the idea behind this is that we have to understand that a function is a certain type of relationship where there is only one output for each input. And the idea comes to us from this over here. This is kind of the reason that we showed this the way that we did, is that in this particular scenario, we had one input, so we had an input of 10, but we had two different outputs. This is an idea of the idea of a function is that this is what we call a one-to-one relationship. And so there can only be one output for one input. So it's like if I put a cake in the oven, I'm not expecting a pie to come out. I should be expecting another cake to come out. So the idea is that we can't have one value plug into an equation and give us two different answers. It just wouldn't make sense. And so a function is just a very unique, special type of relationship where you have one unique value for every number that you plug in. If you plug in a number, you get the answer out. You plug in that number again, you should get the same value back. You wouldn't expect to get two different answers when you plug in the same number always. So the example that they give you is that y equals x to the second. If I plug in 3, my answer will always be 9. It will never be anything different. So the idea is that for a function, if you plug in a number, you're going to get exactly one answer back. And so here, what we can do is we can recognize what makes a function versus a relationship. So first of all, we're going to talk about this as being a relationship because all relationships or all functions are relations. So the given relationship represents the amount of gas in gallons and the distance traveled in miles from that amount of gas. So the idea is that gas ends up being our input. You tell me how much gas that I am going to put in my vehicle, and then I can tell you how much or what distance that I can drive. So my distance ends up being my output. So we're recognizing what we're given and what we're getting back. And so the idea is that we have 10, 150, 16, 240, 17, 240, and 20, 300. Now the idea is that we do have a repeated value. But if we look at this, the idea is that it's one output for each input, meaning that in this particular fashion, and I'll write this down on this paper, the idea is that inputs are not able to be repeated. So I can't plug in the same number and get different results. But I can plug in two different numbers and get the exact same result. Because maybe there's a situation that gets created that I can think of that maybe I get the same answer but with two different answers. So the idea that I can best describe that as is that negative 3 to the power of 2 is 9, and 3 to the power of 2 is also 9. So the answer that I get is exactly the same. However, the number that I plugged in are two different things. So the idea is that inputs, we're looking for when inputs are repeated to make this not a function. So what we can do is we can have the same answer over and over and over again, but it's the number that we plug in must have its own unique answer as a result. So when we look at this, when we're trying to decide whether this is a function or whether this is a relationship, the idea is that because there are no values that are stacked up on each other, the idea is that we got two different answers here from two different values, or we got the same answer from two different things. So notice how above we had our domain go to two different ranges, but down here we had two different domains go to the same range. That is okay. This is perfectly fine. We just have two different values that give us the same answer. And when we graph them, the idea is that notice how this is different from the previous graph where these are side by side, where our other graph they were stacked up on top of each other. So this makes this a function because the idea is that the input is different and then the output is the same, which is okay. It has its own unique value. Okay, so continuing the problem that we looked at, our domain in this particular problem was that we have a curly bracket, we had 10, 16, 17, and then we had 20. Then we can end our curly bracket. And the domain represents the amount of gas, and that's what the label is. So that would be the amount of gas in what we called gallons. The range is going to be all those values that we got as answers. We had 150. We had 240, but I'm not going to write it twice. I'm only going to write it once. And then we had an answer of 300. This represented the miles traveled. And that was, again, just to kind of reiterate, that was in miles. So what we had is that for an input of 10, we had a output of 150. For an input of 16, we had an output of 240. We had an input of 17, and we had an output of 240. Notice that this is where that kind of repeated value comes from, but because each of them were different, then that means that that's okay. And we had an input of 20, which resulted in an output of 300. And so this relationship is actually a function because each domain value, so 10, 16, 20, 10, 16, 17, and 20, were each paired with one unique range value. Even though that range value was repeated, it was paired with exactly one. It's not like I had two values of 16 give me two different answers there. It was this idea that I was able to have each domain have its own answer, even if that answer is repeated. All right, so let's look at another example of this. So the relationship that we're given, what we want to be able to do is we want to be able to give the domain and range. So we want to give all the x values, we want to give all the y values. We want to state what the inputs and the outputs are and whether that this is a function or not. So we have a relationship that represents the number of books sold and the price of the corresponding number of books. So if we bought 2 books or we sold 2 books, the price was $4. If it was 3 books sold, it was 6. If it was 4, it was 7. If it was 5, it was 9. So by looking at this, we have our graph here that we have all of our information. Notice that everything is kind of going up, which makes sense. The more books I sell, the higher the price is going to be. Now we have a mapping diagram that shows our outputs and our inputs. So this is our inputs over here. This is our outputs. So the books sold kind of drives what our price is. And so our input is actually our domain. And so by looking at just the mapping, we can see that each input is exactly paired with one output. This is the perfect scenario to show that this relationship is a function because everything is paired with one other thing, and that's the perfect scenario where we get one input with a corresponding output and it's exactly in that fashion. And so the idea is that we need to talk about our domain. So we're going to list all the values of x, or all the values of our input. In this case is 2, 3, 4, and 5. And so each one of those has its own unique range. And so the idea of the range is that those are our output, which is 4, 6, 7, and 9. We don't care about what the pattern is. We don't care about that. If I buy 3 books, I can get the 4th book for just $1 more. But the idea is that there is a specific relationship. It's a one-to-one relationship, as we call it. So one-to-one relationship, where every one input has exactly one output. That is what makes what we are going to refer to as a function. And so this in particular, selling books and getting a price for it, is a function. Okay, so now we can, with a graph, we can figure out very quickly if a relationship is actually a function or not. And it's something that we call the vertical line test. The vertical line test basically takes a vertical line, and you can see that there are several vertical lines drawn over here. The idea is that it takes a vertical line and it draws it through the graph. And if for some reason we have a point right here, so we're talking about age and height, and this was kind of the first problem that we dealt with here. If we look very closely, what you can see is there's actually 2 points. I'll put that in a different color for you. We can actually see that there are 2 points here with our original function that we dealt with. The idea is that it can only go through one point. This is the idea of that one-to-one relationship, that every one value that this goes through, no matter what it is, should only have one point that it's associated with. So age 7, there should only be one point for it to be what we call a function. Now this is kind of taking the context and moving it a little bit, whether it's any number of children, whatever their heights are. That's just a relationship. But a function would talk about how quickly or how slowly one particular student grows from age 6 to age 7 to 7 to 8 and on and on and on. So the idea is that you have to ask yourself a question: does the vertical line touch more than one point? If your answer is yes, it is not a function. So the idea is the vertical line test is a very quick and easy way that we can decide or we can describe if something is a function or not, because right through here this passes through 2 points, and so that's not good, and so that's what makes this not a function. Now if we were to look at something that is a function, we can draw a vertical line through every single point. So we go through this one right here. Does that touch more than one point? And the answer would be no, because there it is right there. We go through the next point. We draw a line right through that one. That doesn't touch more than one point. There's one right next to it, but it doesn't cross through the line. I draw another one next to that other point. There's not more than one point there. I go through this one too as well. There's not more than one point. So does the vertical line touch more than one point? Your answer is no. Since a vertical line does not pass through more than one point, the graph, what we call, passes the vertical line test, so the relationship is a function. And so the idea behind this and why this vertical line test works is because it identifies that you have more than one answer for one given input. So the vertical line test works because it tests for one input having more than one output. Because if we go back to what we originally talked about, the idea is that it doesn't pass the vertical line test because that first problem with the boy's height, it passed through more than one of the same value. We had that 10 repeated twice with two different answers, but the idea is that's just a relationship. It doesn't mean that it's not something that is real. It's just it's a relationship where a function would talk about a single person growing in height. And the idea behind that is that as a person at a certain age, you couldn't have more than one height. You couldn't be 10 years old and be 36 inches tall and then 45 inches tall at the same time. Now at different times, yeah, maybe, but the idea is at one particular point in time, you cannot be two different heights at the same time. And so the idea is, how do we use this vertical line test? So I'll show you. So as we kind of look at this, what we can do is we can just draw a line on our paper if we want to. And so if we draw a line, the idea is that we can slide it from left to right and see if it passes the graph in more than one spot. So the idea is that what we're looking for is we're looking for this possibility that we have more than one answer at the same time. But if you notice, as this passed through, it really only intersects the graph at one point. Yeah, the line is a little bit bigger than what we need, but the idea is that there's no overlap. The idea is that this goes from left to right without going back on itself. And so the idea behind this graph is that yes, this is a function. And if I go back to the other question here, so the idea is that here you can clearly see that this is going to fail the vertical line test, because here and here it's the exact value of, let's say, that looks like -6. It's -6 in the x direction, but it's these two different values at the same time, which is not something that can happen. And so this is no, not a function. So the idea behind this is that what you're looking for is you're looking for that kind of two different times that this graph is touching the same line or a vertical line to show you that a particular number on our graph is trying to be two things at once. And so the same idea happens here when we're trying to look at this value right here. The idea is that this is two things at once, and that's not going to work. So 0 can't be, looks like -2 and +2 at the same time. It can either be one or the other, but it can't be both at the same time. And so this is going to wrap it up as far as our Unit 2.3 notes are concerned, our 3.2 notes are concerned. So just make sure that you have those all written down, and we'll go over this more on the next class that we're together.